Okay, great. Okay, so we're just going to continue on from last week. Can you guys hear me? Can I hear any of you?
I can hear you.
Okay, cool. And I can at least this time hear you guys as well. Cool. Okay. So let's just go on from last week. So last week we focused on the first 3 study units. And then this week we're going to continue with study unit 4, but first I want to just go through a few examples of stem and leave, because I've seen there was nothing in your assignments. So let's just do that. Just want to see. Okay, so as we go on, I just want to quickly add the link. Okay, this is weird. The link is there. Okay, so let's continue. Okay, so we're looking at the stem and leaf, and in the stem and leaf they can ask us basically a few things that we need to look at, like they ask us when we looked at the normal table that they've given us. So in the stem and leaf they can basically ask the similar kind of questions. So they normally ask about the range. They can ask you about the mean mode. They normally won't go the route of standard deviation and those kind of things, because normally there's too many observations. So they normally stick to those other 3. Okay, so let's look at what they are again asking us. So we need to look at the incorrect one. If somebody can just, I see there's people asking about the link in the chat. If somebody can just paste the link again in the Teams site, it will be nice while I'm going on. So basically, to work out the range, we look at the biggest number, which is the 73. We subtract the smallest number, which is 41. So your range is 73 minus 41, so it is 32. So that one is correct. So we need to then look at the next one. Okay, they talk about they talk about the mode here. So, and they tell us there's 2 modes. So let's just see what is happening in this data. So 41, 45, 48, 50, 52, 52. So there's 2 52s, 55, 59, 61, 62. There is 2 65s, 2 66. So the mode is actually 52 and those 2. Okay, so that one will be the incorrect one, because there are 3 modes and not just 2 modes. Okay, let's just look at the others as well. The fifth largest, so remember that is for 73 is the largest, so let's go backwards. 1, 2, 3, 4, 5. So the fifth largest is 66. Okay, so that is correct. The median is 61, so let's look at where is 17 cars. So what is 17 divided by 2 is 6, no, 7, 8. So there will be 8, then there will be the mean, and there will be 8 to the other side. So let's look at the ninth number. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so 61 is the median. That is a correct one. And the mean is the measure that is affected by the outlier. Okay, so let's look at the mode is not affected by an outlier because the mode is just the number. So if, say, here was a number 91, the mode, and there wasn't the numbers 73, so it still was 17 cars, but we just replaced 73 by 91. So the mode still stays the same. The median still stays the same, but your mean will change. So your mean will be the one that is affected by an outlier. Okay, so just by whatever that big difference is, that will have the impact on your mean. Okay, so that nearly gives us a indication of what they can ask in a STEM and leave, but I've got 2 more examples just to show how it was asked in some previous exam papers. Okay, so let's go to the next one. So again, let's look if the data was, okay, no, it's at least a different data. So again, you can see it's a lot of data points. So again, on this looks like about 20 data points. They will not ask you on a STEM and leave with this much data that you do standard deviation or variance or those kind of things. So they will stick to things around median, mode, and mean. The range that then includes the biggest and the largest number. They might look at quarters and those kind of things, Q1 and Q3, but definitely not the variance and the standard deviation. Okay, so incorrect one. So they've asked us the first one, the range. So the range is the biggest, which is 86, minus the smallest, which is 36, so that is 50. That is correct, so we need to move on to the next one. The fifth largest value is 50. Okay, so largest. 1, 2, 3, 4, 5. So the fifth largest value is actually 80. Okay, so what I think is if you count it from the other way, 1, 2, 3, 4, 5, you would have gotten 50. Okay, let me just Okay, so then that could have been easily a mistake that you could have made if you were sitting and counting from the wrong way. So just make sure when you look at that that you do it correctly. I just want to just in a few links everywhere. There are 53 numbers, so the 53 numbers you basically need to count. So it is 6, 8, 9, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so there is 33 numbers. There's no other ways of doing it by just counting it. So that's a way to do it. The mode is 70. So here we need to check again for 70, but let's look at all of them. Okay, so there's 251s, 253s, 264s, 370s. Okay, so the mode is definitely 70. Okay, so then the median is 64. So if we look again at the median, remember median is the one that is in the middle. So if there is 53 numbers, what is 33 divided by 2 is, what is it, 16. 16, then will be one in the middle, and 16 again. That will give you 53. Okay, so 16, 1, 16. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that is the middle number, and then there will be 16 again. So 64 is your median. Okay, so again, basically what we've seen in the stem and leaf, and there is another one that we are doing next lot or after this one. So again, we look at things that we can include here, mean, median, mode. So you will see that that is what basically we see the most of the time. Okay, this was in one of the exam papers, and then the following semester, very similar one was also asked in the exam paper. So you can see they like to use the same kind of questions. So what I also did was I included some of last year's online mock exam as some of the things that we will work through today as well. Okay, so let's look basically the same question, but somewhere else there's one of the things that are wrong. So you can again look at the ones that they now change in this question. So the range is 50, so that one stayed the same. It was the 86, your largest number, minus your smallest number. So that question basically stayed the same. 86 minus 36, that is 50. The smallest value. So now actually the smallest value is 1 or the fifth smallest value is 1, 2, 3, 4, 5. So that is 50. Okay, so it wasn't that one that was in this exam, the wrong one. There are 33 numbers.
Gene?
Yes.
Sorry, man. How do you know when you count from the top and when you count from the bottom?
So basically, this data set begins at 36 and it ends at 86. So remember, you will always arrange or sort your numbers from smallest to largest. Okay, so in any, even if when we did this table, where was it? This one, we started with the smallest and you go to the largest. So that is just that you first need to remember whenever you sort a data set, smallest first, largest last, basically. And then if I ask you then the smallest one, you start at the bottom. If I ask you the largest one, you start at the top. Okay, does that help a bit?
Yes, thank you.
Cool. So remember always when you sort data, smallest to largest. Okay, the 33 numbers, I'm not gonna count again, but there is definitely 33 numbers. Let's look at the mode again. So the mode is the value that occurs the most. So that's all single numbers. So 51, 55, those appearing twice. 40 or 64 appearing twice, and then 70 appearing 3 times. There's no other number appearing 3 times, so the mode is 70. If that was only 2 numbers, then the mode would have been 51, 55, 64, and 70. Okay, so if there was only 2 70s, then there were actually 4 modes. Then the median, so we know the median is the number that is in the middle of the data set. We know there's 33 numbers, so 60 numbers to the one side, then your middle number, and 60 numbers to the other side. So your middle number is observation 17. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay. So if you are pressured in the exam and you need to quickly finish, you see the number 4, you see number 4 and you think it's correct, but actually this value is number 64 and not just 4. Okay, so you need to remember it's 64. So the median in this instance was the wrong option. Okay, so that's nearly a summary of a STEM and leave if they do ask that in the exam, because it wasn't in any of the assignments. We'll see if it is in the mock exam, but I don't know yet. Okay, so questions on the STEM and leave.
Morning, Jean.
Morning.
What if the median is, let's say, an even number?
Okay, cool. So let's say the median was, let's take that one away, and we say we had actually 32 numbers and not 33. So then your number is, and how we then calculate it is 32 plus 1 divided by 2. So your numbers will be between two numbers. So then it would sit between those two numbers. And this instance, it was the same. But if it was then between those two numbers, it will actually be 63.5. So that it is between 63 and 64. So you will basically, and let's not do that, you will basically add the 63 plus the 64 and divide it by 2. So wherever there is an even number, then it will lie between the two numbers that is in the middle, and then to get your median, you need to divide the sum of those two by 2. Okay, so most of the instances, your stem and leaf will be uneven numbers, but we know exam time, it can vary, and they can throw something else at you, but then you basically add the two middle numbers and divide by 2. Okay. Any other questions on stem and leaf? So the things, let me quickly see. So the ones that they haven't asked, so sometimes they ask you what is the minimum and what's the maximum. Also, what you need to look out for is how that is structured. So here they sometimes your data set. So this one was representing gasoline purchase in gallons. This one was data on for the days to maturity. There could be an instance where this was the same because it was the same question. There can be instances that this data set is not like we had here, 36, 38. It could be that it represents a decimal, a 3.6 or 3.8, but then it will be in the question, because sometimes I'll look for another one where it is, and let me just make myself a note now that I remember it from a past question. I think it was in one of the older assignments. Let me just stem and leave. A decimal. Let me just, I'll add just one for next week. I'll go and look for it so that we just, again, if there is something different in the question sets that we do cover it. So I will just add that to the pack next week, and we can look at one or two other ones. Just that we cover everything. Okay, on the last question, nearly, I think on that chapter 3 that I wanted just to show, we haven't looked at questions where they look at a distribution and how it is or normally distributed or skewed to the left or skewed to the right. So I just thought let's just include one of those questions. So which of the following statements is correct? Not a lot of times that we get that with regard to negatively skewed distribution. Okay, so if something is negatively skewed, so let's just, I'm going to try to, so that's your normal bell-shaped curve. Let's do hopefully a positive skewed is something like that, and negatively skewed is something like that. So in a negatively skewed one, let's just see what happens. So if it's a bell shape, your mean, median, and mode are all equal. Okay, so we're looking for the correct one, so that is definitely not the correct one. The other four speaks around these two. So the mean is less than the median, and the median is less than the mode. Okay, so on the paper that I nearly did a summary, your positive skewed is your mode is smaller than your median, and that is smaller than your mean. And your negatively skewed, the one that we are looking at, your mean is smaller than your median, and your median then is smaller than the mode. Okay, and where it is the bell shape, mean, median, and mode is all equal. So the mean is less than the median, that's correct, and that is less than the mode. Okay, so that one is definitely then correct. Let's just look at the other ones. The mean is greater.
So, Jean,
Yes.
I just want some clarification. The plus and the minus, shouldn't it be changed around for the graphs?
No. So this is positively skewed graph, and that is negatively skewed graph. Positively skewed is also you get a tail to the right. So that is the other one that they can use. And the negatively skewed can also be tailed to the left. So let's quickly copy this in. Now mine just looks so that those two is supposed to look similar. And those two are supposed to look similar. Mine just looks way much more amplified, but it's skewed. Okay, so I've added that from the textbook as well. Thanks for that, is it Christina? And let's just copy. Undo. Okay, so there's the from the textbook. Oh, and it's in the study guide, page 53 to 54. So that's probably where I also got it from. Okay, is that then all right, Christine? That
Yes, thank you.
cool. Okay, so thanks for that. Yeah, so and just look, they want to confuse you with the rest of the. So in this one, mean is greater than the median, and the median is greater than the mode. So that will be a positive, skewed positively. So let me just add that one. That will be skewed positive because you look at it from this side, the mean is greater than the mode, which in turn is greater. So they basically swapped those two around. Okay, that is just wrong. The mean is less than the mode, which in turn is less than. Okay, so that one is also just, there isn't one. Okay, so that would have been the bell shape. That would have been the positive. That was the negative we were looking for. And the last two is just not part of any of them. So the last two were there just also to nearly create a lot of confusion. Okay, so, and they like to ask this nearly in the exam. And it will probably not be that they ask which one is the bell shape. It will probably be one of these two that they will ask. So just as an add-on, I think this is also important to look at. Okay, so that nearly was the questions from chapter 1 and to chapter 3. We have started with study unit 4 last week, but I think a lot of you guys said that this is one of those study units that really is a bit much more difficult than the rest to understand. So I think I've included a lot of different questions on this and from previous exams and mock exams, and so I think this one we can really look at today to just make sure that we have a good understanding of study unit 4. Okay, so this one is a very straightforward question. Let W be the event that the distance from home to school is less than 3 kilometers. Determine the probability of event W occurring and choose the answer from a list of options below. Okay, so what is the probability of W happening? And W is, what's the probability that kilometers is less than 3 kilometers? Okay, so let's see how many are less than 3. That one, that one, that one. So there's 3 that is less than 3. How many is in total? 3, 4, 5, 6, 7, 8, 9, 10. So this one was straightforward. 3 observations less than 10. Out of the 10 observations, that is 0.3. So the probability that there is 3 observations less than 3 kilometers is 0.3, which would have been the first one. So let's just, if I said less than 2 kilometers, it would have been 2 divided. If I said less than 1 kilometer, there was nothing. If I said less than 12 kilometers, it would have been all of them. So just dependent on how much they say, you can change it on the scale to say, okay, less than 6 would have been those 1, 2, 3, 4, 5, 6. Less than 8 would have been that. Less than 10 would have been that. So this one is much more straightforward. You just look at the numbers and you decide on that distribution what you're going to pick. Okay, so less than 3 kilometers was that. If we needed to get more than 3, it would have been the rest of it. So more than 3 kilometers would have just been 0.7. Okay, and then you can look at those two to say, well, I also could have said it is 1 minus 0.3. So I actually have worked out what is the complement of that. Okay, so that's another way that they can ask you is if we're looking at the value of less than 3 kilometers, what is the complement? The complement is then the opposite, so it would be the 0.7. And again, you could have worked it out via the table to say, okay, there's 1, 2, 3, 4, 5, 6, 7 values. Or you could have said, if we're looking for complement, we know the complement rule is 1 minus the probability that we have calculated. Okay, so that's nearly the first rule of a probability, is first to work out what the probability can be, and then looking at the complement. But I think there is other ones that we're also looking at complement. Then they can ask you that in a lot of different options. So they can start then to make the table bigger to include a different variable. What they can also do is, like this one, they give you the totals, they ask you a few questions. The same in this one, you can look at, so this was from a previous online mock exam. So you can see there was a few questions on that. Then they can ask you, so this was Poisson, I need to just move that out. I just want to get to that. So they can ask you the ones with the tables. Then they can give you it as just the one probability, the other probability, and you need to work out this. They can also again give you the same and ask you something different. In this instance, they gave you also a table to work out things, but they also gave you areas that you first needed to calculate the difference. And again, they can nearly ask you some of the other things like complement, mutually exclusive, those kind of things. So there is a lot of different types of questions that they can ask you in the probability, and I think that is nearly also the difficulty with this study unit, is there is just so many things that they can ask. Okay, so let's look at this question. Let's see if I can make it at least a bit bigger. We can go to the options later on. Okay, so they ask us, consider this table, calculate the probability that a random chosen learner travels between 3 and 6 kilometers from home to school, given that they are in high school. Choose the correct answer from the list below. Okay, and then so remember given. Okay, so in this instance, we need a few totals. So we need that total 800, so that at least is the total. Here we need that total, so it looks like 280. Okay, so we're working and we need that total. So that is 160, 160, 320. Okay, so can you guys remember what the formula is when we get something that is a given? Okay, so let's just write that down. So if we look at the conditional formulas, does so let me quickly see if I can copy that out here, then I don't need to write it down. Let's see if it that's weird. So let's just see if there's a okay, go. Okay, so that is the formula that we are looking at. So probability of A given B is the probability of the AND divided by the probability of B. So probability of A and B, so we're looking at the AND divided by the probability of B. So if that was probability A, because it is, we said it is given B, I just want to make sure that they are in high school, so this is probability B. That's the probability of A and B. So how do we work out that probability of A and B? I just want to show you something so that it normally cancels out. So I just want to make 100% sure. Okay, so the probability of A and B is the 112 divided by 800. And if I make a mistake, please just correct me. And then the probability of B is 320 divided by 800. Okay, so what we could have done, because we are dividing by 800 in both, is we could have just said it's 112 divided by 320. And that will give us the same answer. So yes, we now did the long way to say, well, to get the probability A and B, if I normally would work it out, it is 112 divided by 800. If I look at probability of B, if I normally would work it out, it is with 320 divided by 800. But in actual fact, the two 800s, because one is on top, the other one is on bottom, it will just cancel out. So here I could have just said the AND divided by the total of B. Okay, and then that will be equal to 0.35, which is option D. Let's just, I want to show you if it was the other way around. So if I said to us, calculate the probability that a random chosen learner is in high school, given that they are traveling between 3 and 6 kilometers. So basically, we just turned it around to say, let's just get another color for this one. So we just turned it around to say that is PB, that is BA. Okay, wait. No, I must rephrase it. So let's, that nearly stays the same. Sorry, I now made it. That will give me the same answer. So let's just rephrase it here. That given that they are in high school, so instead of given that they are in high school, we say given that they are between 3 and 6 kilometers. Let's just change those two. We're not changing the formula. So we keep it as probability A given B. I still want that one, but I just want to know if it is given the 3 to 6 kilometers. So you would see your and stays the same. So your and stays 112. So there's no problem in the and, but now suddenly your PB is looking at this part, so it's the 280. So if you then did that calculation, 112 divided by 280, you get 0.4. And I think, oh, luckily there isn't an option. Okay, but just how simple one can make a mistake by using the other option instead of, so if we did it the other way around, it would have given us 0.4. Okay. So they can ask that in a few different ways. So let's get to another one. Okay, so let's, okay, so here they give us the ISC recorded the following information about registered voters living abroad. So here we have people living in Australia, New Zealand, UK, male, female. So now they are asking us a few questions around that. So what we're now asking is questions about independence, and then questions about mutually exclusivity. Okay, so now again, it is important to understand what those rules are. So if something is mutually exclusive, the probability of A and B will be equal to 0. Okay, so let's look at this data set. So to be mutually exclusive, you can't be in Australia and New Zealand at the same time. So then it's mutually exclusive. You can't be in New Zealand and the UK all time. So mutually exclusive is when you can't be in one of those at the same time, and obviously you can see when this was set up in 2019, there was way other discussion. So just go back to that stage, and male and female was also seen as mutually exclusive. So let's look at those two mutually exclusive questions first. So events UK and female are mutually exclusive. Female UK, there is a number. So if we divide that by 580, we will definitely not get 0. So that is incorrect. Events male and female are not mutually exclusive. Again, if we look at that, you can't be male and female. So that is also incorrect. So the mutually exclusive one is sometimes easier to do when we have a table, because you can definitely out of a table already see if it's mutually exclusive or not. So let's look at the next one of independence. So with independence, you normally need to work out a few things, but let's just look at the bottom one, UK and female. Okay, so here they actually, with that rule, they're talking about mutually exclusive when UK and F is equal to 0. So you can see that's the mutually exclusive rule and not the independence rule. So that one we can also, but for mutually exclusive, the probability of A and B is equal to the probability of A times B. Okay, so that is your, oh, sorry, did I not say mutually exclusive? That is your independent rule. So for something to be independent, that is the rule. Your probability of A and B is equal to your probability of A times your probability of B. So let's look at these two questions. Events AU and female are independent. Okay, so the probability of A and B, so remember we're looking at AU and female. So the probability of that is 52 divided by 580. And we say that that needs to be equal to the probability of A, which is, what's the probability of A? So the probability of A is 102. So that's the probability of living in Oz times the probability of being a female, which is 260 divided by 580. Okay, so if those two are equal, then we have, will that be 102 divided by 580? $176. $448. Okay, so they say that is about 0.0789. Let's do that. 52 divided by 580. 7. Okay, so those two are not equal. Okay. One can very easily make that mistake in the exam again because you've got the 7, the 8, and the 9. But okay, so those two are not equal. So the events AU and female are not independent. So we're still looking for the correct one. So that is not correct. So that one will be correct. But let's also work it out. The event UK. So now we're looking at UK and female. So we're looking at the 143. So the AND is 143 divided by 580. So we say that must be equal to the UK, that is 319 divided by 580 times the female, and that is again 260 divided by 580. So let's see if that gives us something different. 319 divided by 580 gives us 0.55. We know that one was 0.448. So 0.55 times 0.448. That gives us something like 0.246. And let's just divide 143 divided by 580. Okay, so this one is the correct one. Okay, so mutually exclusive is that formula. Independence is looking at this one. So again, that is nearly 2 of the questions that they can ask, and we'll now cover the ones that they ask it where it's not in a table, so that we need to know that use those formulas as they give that to us as well. Okay, let's just do a quick check-in. Does it make a bit more sense than previously? So that we just continue to, okay, cool. So let's continue to the next one, which was also in one of the old exam papers, or the old mock exam of last year. So again, looking at the same data set. So here they ask us again a few questions. Now we're looking for the incorrect, but now you can see they're asking us basically the ones that we did about 2 or 3 exercises ago. So what is the probability of M? So let's look. Okay, so that must be M, that must be F. Probability of M is 320. Probability of UK, you're going to be 319. Okay, so that rounding off, it will probably give you the same answer. Okay, yeah, so rounding off, it actually gives you the same answer of 0.55. Obviously, there's one difference, but if you round it off to 2 decimals, it's not gonna be any difference. So if you round it off, 320 divided by 580 is going to be the same as 319. divided by 580. Okay, but that's to 2 decimals. I don't like this one because I would have said it's not correct. Let's look at option 2. So what's the probability of AU, so Australia, and female? Okay, so they're basically asking us to work out that and they tell us that's the same as the probability of AU and male. Okay, so again, looking at decimals, it will be the same. If we just look at numbers, it is not. Okay, I don't like this question at all. But yeah, so the trick merely is in this one that you need to round it off to 2 decimals, then it will be what they are giving us. Okay, so that one is correct, that one is correct. Probability of UK and M. So UK and M, so it is the 176 divided by 580. So 176 divided by 580, it gives us 0.3, so that is also correct. Okay, so here comes in the probability of UK given M. So the probability of UK, so we know then that we need to say that formula is the probability of UK and M divided by the probability of M. And how I remember that is at the top it is the AND of those two, and at the bottom I divide by the last one. Okay, so the probability of UK and M, UK and M is 176 divided by the probability of M, which is 320. So hopefully 176 divided by 320, it gives us 0.55. Okay, so that one is also correct. So that one will be incorrect, but let's just do that. So again, the same probability of UK and female divided by the probability of female. So that is UK and female stays the same, 176. No, it's not. Sorry, UK and female, not UK and male. UK and female, it's the 143. Given that they are female, 260. So that answer should be 143 divided by 260, which also should give you 0.55. That's quite interesting. Okay, but that is also 0.55. Okay, so it should give you 0.55. The answer that they give us is 0.25, so that is why this one is wrong. So basically from the same table, where they also ask us about mutually exclusivity and independence, they can ask us to work out just the normal probabilities of certain options. Okay, and then we go into the probabilities where they actually don't give you a table. So here they only tell you, okay, probability of A is that, probability of B is that. Consider events A and B as mutually exclusive. Okay, so what do we know if it's mutually exclusive? The probability A and B is equal to 0. Okay, so now let's look at the question that they then ask us. So we need to work out the probability of A or the probability of B. Okay, so the probability of A or B. So that formula is also in study unit 4, but that is basically the probability of A plus the probability of B minus the probability of A and B. Cool. I'm also going to copy it in. Okay, so let's just complete it then. So we're still looking for that one. We've got probability of A. We've got probability of B. In that question, they don't give us that answer straightforward, but they told us that it's mutually exclusive. So we know then that we subtract with 0. And then probability of that plus that is equal to 1. Okay, which is then option 2. So in this one, they basically didn't tell us what your mutually exclusive is. So you need to nearly remember out of your formulas that mutually exclusive means the AND is 0. So when we write or work that out, that part is 0. So we actually just add the first 2. Okay, so that's mutually exclusive. So obviously, after mutually exclusive, we need to have an independent one as well. So I think after today's session, we would have covered this very well so that you guys are well prepared with study unit 4. So, okay, so again in here, they give us those two probabilities. But now I say probability of A and B are independent. So if it is independent, we know that A and B, how we work it out, will be probability of A times probability of B. So that will be 0.35 times 0.65. So the probability of A and B will then be 0.228 if I round it off to 3 decimals. If I rounded it off to 4 decimals, that would have been your option. So again, in the exam, if you had rounded that off to 4, that would have been your option. And again, you can maybe make that mistake to pick that one. Okay, but it's not. I don't think that will be your final answer. So it is 0.35 plus 0.65 minus the and, let's just say 0.0075, and that then is 0.35 plus 0.65 minus 0.2275, which gives us 0.7725, okay, which is that option. Let me just check one thing for you. Okay, so you can also see it's nearly the same answers that they've spread across. I just want to highlight in both of them, you can't get a probability bigger than 1. So that is nearly already, you take it out. You can't get a probability that's more than 1. So that is one of the options that you can, from the start, nearly eliminate out of your option set. Okay, so we basically, I just want to check if there's another one. Okay, there's 2 left. So we have covered nearly all of your rules now, with the independent one, the mutually exclusive one, the given, the and. So 2 last ones. So let's do this one first, and then we can do the table next before we go into study unit, since we are now on this mutually exclusive and independent. So we've asked that question now in a few different ways. So let's look at it, nearly a final one that they can ask us. So also look at the incorrect one. If 2 events A and B are complementary, then A plus B is equal to 1. Okay, so that is correct. So if I have A as 0.5, then I can say if B was the complementary one, B is equal to 1 minus 0.5, which is 0.5. So then if I say probability of A plus B, 0.5 plus 0.5 is equal to 1. Okay, so we nearly have shown that it is even true. I just now used 0.5, but let's say A was 0.6. Then probability of A plus B then will be 0.6 plus 0.4, which also gives me 1. Okay, so the complementary one sorted. If 2 events A and B are mutually exclusive, then the probability of A and B is equal to 0. That we've now covered a few times in the previous question, so always mutual exclusivity. That is correct. So that is what it means. If 2 events A and B are independent, the probability of A given B is equal to the probability of B. That is an interesting one. So that one I'll show you now with an example. Given probability of A and B equal to that, and probability of B equal to that, if A and B are independent, then probability of A is. Okay. So this one we need to work out backwards again. So let's just start it here. We know that if probability of A and B are independent, probability of A times probability of B is equal to that and. So I'm just going to write it the and. So they've given us the and is 0.4. They tell us the probability of B is 0.5. So we need to work out if that probability of A is then equal to 0.8. Okay, so how we do that, I keep the probability of A on this side. I divide both sides by 0.5, so that the 0.5 on this side cancels out, but I need to do it on both sides. So 0.4 divided by 0.5, it gives me 0.8.
Sorry, Jean.
Yes.
You lost me a bit there. Why are you dividing by 0.5?
Okay, let me do that again. So let me just write for one side. We have the probability of A. We know what probability of B is, so we replace it. And we know what the and is 0.4. Okay, so I want to isolate that probability of A because that is the answer that I'm looking for. So to isolate that, I need to get rid of the 0.5. Then the only way I can get rid of that 0.5, because there's a multiplication where I need to divide that whole thing by 0.5 to get rid of that 0.5. But from maths, what I need to do, if I divide on the one side by 0.5, I need to divide the other side by 0.5 as well. That is just the maths rule. So on this side, the 0.5 and the 0.5 cancels out, so that I am left with the probability of A. And then on this side, I need to divide by those two. So 0.4 divided by 0.5 will give me 0.8. Okay, is that a bit more clearer?
Yeah, thank you.
Cool. Okay, so we've done A, we've done B, we get to C, we've done D. If two events A and B are complementary, then A and B must be mutually exclusive. Okay, so if A is 0.4 or 0.6, like we did there, B is 0.4, and if we say probability of A or B, that must be 0. So your A and B needs to be 0 because we can't get something that's bigger than 1. Okay, so if two events are complementary, they are actually also mutually exclusive. Okay, that's the first time I see that they're asking a question like that. And it wasn't nearly, I don't think it was even handled in the study guide, but that actually makes 100% sense, because if it is complementary, there is not a and, because the two complementary ones will add up to 1. So it's basically what we've done here is when the 2 added to 1, the and was 0, which means the and is mutually exclusive. Okay, let's get to that C, because that's actually a good one just to round this off with. So probability of A given B. So if we write that out, it is the probability of A and B divided by the probability of B. So if we look at it being independent, we know that A and B is actually the probability of A times the probability of B. We've now seen that numerous times with the previous options, the previous work, but if they ask us if it's independent, we say probability of A times probability of B is the independent. And okay, so now we see that at the top there's a probability of B, at the bottom there's a probability of B. So those two will cancel out because they're the same at the top and at the bottom of the division. So we're left with probability of A. So if two events A and B are independent, then probability of A given B must actually be equal to the probability of A and not the probability of B, which makes option C the wrong one. Okay, but this basically I worked out by using the formula. There's no shortcut nearly in that one. Okay, so the same nearly if it was probability of B given A and it was independent, then also it will be probability of B times probability of A divided by probability of A. So the two probabilities of A would have cancelled out, so we would have left with probability of B. Okay, so for me, how I remember it is nearly, if it's independent, that will be your answer that you're left with, is the probability of B's, or sorry, the probability of A. So in this instance, it's turned around, still independent. What you're left with is nearly that first probability of B. Yes, Christine.
No, you just said what I wanted to say. Thank you.
Okay, cool. Yeah, so again, that's a nice shortcut to nearly look at when one sees all of these different things. I also just putting that one in there so that we have that for you when you use this slide back for exams as well. Okay, last one on this study unit. I think we've covered it well today. So this is nearly the last thing that they can do. And I think in one of your assignments, there was one that they actually didn't. I just want to, yes, where that was a blank, where they actually should have told you that it's not 0 and should have nearly done what was done in this one and tell you that you need to complete the missing information. Okay, so let's look at this missing information. Okay, so if that is 120, that's 150, that must be 30, because 150 minus 120 is the 30, but we could also have said 19 plus 11 gives you the 30. Then to get to that one, we could also say 150 minus 97, which will give you 53, or we can say 42 plus 11 to give me the 53. Okay, so then at least those two blanks are now filled in. So now we can go to the rest of the questions. Okay, so let's event woman and type A is mutually exclusive. Which one is correct? Okay. This is definitely not. Let me just take that out. That is definitely not correct. So event woman and personality is mutually exclusive. Woman type A. So there is a and. So if there is a and, it is definitely not mutually exclusive because the and needs to be 0 to be mutually exclusive. So that one is incorrect. Okay, so let's look at the next one, the probability M given B. Okay, so probability M given B, so it's the probability of M and B. M and B divided by the probability of B. Let me just check. Type B, so that is the 53. Okay, so 42 divided by 53 is not going to give us that answer, so it is 0.792. So that one is also incorrect. Probability of W and B. So probability of W and B, so 11 divided by 150. Zero comma 0.073. Okay, correct one. But let's look at probability of woman. So probability of woman is the 50 divided by 150, and let's just hope that is also now not giving me. Okay, luckily not. 0.2 it should be, so that is also incorrect. So those two are probably turned around, so I'm thinking that answer is going to be 0.35, but let's just, probability of B is 53. Oh, wait, it's not, it's the probability of B and M. I just want to, let's just clear a bit as well. I'm going to put in the 50 now. Okay, so the probability of B and M, probability of B and M, so again we're 42, but given M, which is 120, so 42 divided by 120 gives us the 0.35. Okay, which makes that one also incorrect. Okay, so again, very important nearly to remember which ones to divide by when you get the given, because if you did it the other way around, that would have been correct. If you did it the other way around, that one would have also been correct. So just very important, if you get the given by what
John,
you need to divide. Yes.
Would you mind just explaining again how to know when you divide by the column and row
Okay, so
and where, if I'm making sense, and when you
yes,
divide
because
yeah,
because I now
so
took a
about the big
shortcut.
total.
So yeah, so now I just now took a shortcut. So when I look at that one, remember when you write out the formula, and how I remember it is you write out the formula as that would be the and, so it's the probability of M and B divided by the one that's at the back. So divide by the given. So in this one, in option 5, the probability would have been B and M, but that is to say B and M, and to say M and B is exactly the same. But the big difference come in with this one, I divide by the probability of M. I say probability of M and then I write down probability of, so probability of M. Okay, and now in both the, again, when I now said 42 divided by 53, I took a shortcut. So probability of M and B, so let's just look at it, M and B would have been 42 divided by 150. So that is how you would normally work it out. If I just ask you what is the probability of M and B, and then the probability of B, if I just ask you to tell me what the probability of B is, it was the total of B divided by the total. So it would have been 53 divided by 150.
Gotcha, and the 150s cancel out, so
And
that's
the
why.
250 cancel out, so that's why I just do the shortcut route nearly. But when you only want to get the probability of M and B, then you need to say 42 divided by 140. It's like 150. It's like what we did here. So when we just wanted the probability of a woman, we needed to say 50 divided by 150. So the same principle that I did here, I took and used here. So the probability of B and M should have been actually 42 divided by 150. And the probability of M should have been 120 divided by 150, which again on both sides then would have cancelled, or at the top and the bottom would have cancelled out. So that's why I'm left with 42 divided by 120. Okay. Any other questions around this?
Jean, mine's not particularly around this. I was just wondering on the contingency table, if the probabilities will always be worked out if you're not taking no shortcuts using the grand total. So meaning 42 divided by 150, 78 divided by 150, if you want the particular probabilities.
Yes. Okay,
you won't use the shortcut method of using just the column totals.
No. So I will add one that your table.
Because I think that's where I was getting confused, is people, or they were, the examples I followed, they probably also used shortcuts, and then I fell off the wagon.
Yeah, no, so they would do that. I'm just making a note to add a table where there is probability in it. I just want to check through those examples. It was always the numbers. I just want to The ones that we did last
No, the
week.
reason I'm asking is because they have you calculate probability. So I try to find a way in Excel that if I plug in the value, it automatically
Yes.
creates my probability table. And then I just take the values from there and use them in the applicable formula. And I was just concerned that if it's not always calculated by the grand total for the probabilities within the table, then obviously my formulas won't work out.
Yeah, no, so always, so when you do it in Excel, I would go this route with the full nearly formula. So I would, and that's why I wrote that down. So what I want to give you guys next week, an extra table where they actually have calculated, because that now I see they haven't asked you any of, so that they give you this. Instead of, let's quickly check. So let me quickly, so they give you a probability within this. So instead of the woman total of 30, they give you a probability of 0.353. And giving you, instead of 120, they give you a probability of something. So I just want to work out this for you. Wait, so that was the wrong one. I just want to know. I thought there's something wrong. So that they, instead of the numbers, they give you probability. So I just want to give you guys that as well. So that, yes, so that if you get, so that is what, yeah, perfect. See, so, oh, and you just added another if there is a third one coming in on both sides. That's perfect. So I want to give you a table if I do this, because I'm sure if I now suddenly give you this table, that there's going to be a bit of confusion what to do next, because all of the examples that they've given us was looking at the raw data. So I just want to make sure if they give us something like this, that we also know what to do. Okay, so next week I'll have one included in the questions. Yeah, because this you can use, so if that then changes, this will automatically changes, so that then if you reference those ones in these, it will automatically update. Yeah, perfect. And when you have the table like this, you know it can't be or it A and B is mutually exclusive, because you can't be A and B at the same time. 1 and 2 will be mutually exclusive because you can't be 1 and 2 at the same time. So if I ask those questions, you actually don't get it from the table, but or you could program that in as well. Yeah. Okay, cool. Okay, so that's the work on study unit 4. So let's start with study unit 5, because the discrete probability is very similar nearly to the things that we have done in study unit 4. It just looks at it nearly when, if I ask you x equal to 0, what's the probability? X equal to 1. So it's very similar to that one that we had, really the distance from a school. We could have nearly plotted that in a discrete variable table as well. So let's look at this, and let's look at the things that they are. So in discrete, there's 3 possible answers that they can ask for. So the one is to say, work out the probability. So that's the one thing that they can look at, and you can see here, there's a probability, there's a probability. The other one is to say, work out what is the estimated value of x. So that is basically asking you to work out the mean. And then the third one is to say, and let's quickly check if there was one like this. No. So I will also then just make a note, is to say work out the variance of x or the standard deviation. So that's basically the 3 things that they can ask us on discrete. I just want to add that, so next time I will have the extra one in here as well. Okay, so for this one, 2 probabilities that they ask us and 2 estimated values. So let's first look at a few of the questions. So which one of the following statements is correct? Okay, remember when any of the probabilities, so the sum of the probabilities needs to add to 1. So 0.05 plus that, plus that, plus that, plus that, all of that needs to equal to 1, the sum of it. So the sum of the probabilities must be equal to 1, so that one is incorrect. So what can happen also is that in your exam, one of these variables, the 0.35 could have been left out, but you first need to complete that and then work with the rest. Cool, I'll copy that in now, Christina, into this as well, the Excel. So that's the first one, is to know all of them are, if you add them up, is equal to 1. So let's look at the other questions. Probability that x is smaller than 1. So it's not including 1, it's smaller than 1. So x smaller than 1 is 0.05. Okay, so that one is also wrong. If it was x smaller or equal to 1, then it would have been smaller or equal to 1, then it would have been 0.2. But just looking at smaller than 1, we exclude 1, so it is 0.05. So that is why that one is also wrong. So let's look at this one. So looking at the probability that x is smaller or equal to 3, so from 3 and bigger and equal to 1. Okay, so smaller than 3 or smaller equal to 3, bigger equal to 1, it is all of those ones. So it is actually 0.15 plus 0.2 plus 0.25. that is equal to 0.6. Okay, so that one is also wrong. To get to the estimated value, again, we'll add that in Excel for you, but just also how that is worked out. Okay, so that we have worked out in Excel for you, but how you work it out is you basically need to say that times that. Okay, so for this it will be 0 plus that times that, so this one would be 0.15 plus that times that, so 2 times 0.2 is 0.4 plus 3 times that is 0.75 plus that times that, luckily it is there, 1.4, and then you would need to add all of them. So 1.4 plus 0.75 plus 0.4 plus 0.15, and that is 2.7. Okay, so the right answer of the estimated mean is 2.7, so that would be your correct answer, and that would have been your incorrect answer. Okay, and then the Excel makes it much easier if we needed now to get to the variance and the standard deviation. So if we needed to get to the variance and the standard deviation, the Excel formula made it just so much simpler, because to again do this by hand to get to the variance, now we needed to say basically 0 minus 2.7 to the power of 2 times the probability, plus the next one the same ritual, plus the next one, plus the next one, plus the next one, which makes it a very long calculation if you want to do it or on paper or even by calculator. Yes, Christine. I'll ask Christina to share again. I think she has shared it somewhere on the group, but there has been a few extra people joining, so I'll just ask her to share again, and then by the end of before your write exam, it will also be all in one Excel spreadsheet that you only need to look at one spreadsheet and one PowerPoint. And the PowerPoint in the end, I will also do a PDF of it that you guys don't need to jump around between all the slides that has been provided. That's why I like to add some of these things already in the PowerPoint as well. So when you nearly in the exam, you can nearly see which sheet even to go to answer your exam questions. Okay, so that's one of the discrete, but they can also ask it nearly in words, which again you will see they basically could have said the probability that 2 learners, so they could have said let's rather say, what's the probability that 2 learners are absent? Which again, just for your exam, just be wary how they nearly phrase it. So it can be that they use the short form or given long sentences, and then you just need to be very sure what you read in it. So the probability that 2 learners are absent, so x is equal to 2. So if x is equal to 2, that is the probability that 2 learners are absent. Okay, so that is correct. Okay, we're looking for the incorrect one. The probability that between 2 and 5 learners are absent on a given day, assume 2 and 5 are both not inclusive. So the probability of learners between 5 and 2, and it is not inclusive, so it is not smaller or equal to 5 or bigger and equal to. So we're not including because it's not inclusive. So because it's not inclusive, it's not equal to. Okay. So if I said inclusive, then we would have said, so not inclusive is that. If I said only inclusive, then it would have been smaller or equal to. So just again the wording that we need to get that right. So then it is only 3 and 4. So it's 0.3 plus 0.15, which is 0.45. So that one is also correct. The probability that at most 2 learners are absent, okay, so at most 2 learners, so you cannot have, great, there's another one coming in, awesome. Is that also in the textbook, or was it from somewhere?
No, I poached it from somewhere else because it helped me a lot.
Yeah, no, this is cool. This is really cool because this nearly gives you all of those words that we struggle with when they give us in a sentence. At least, no less, at most, no more. I love it. This is great. Thanks. Because this is really the ones that we struggle with when we give it in sentences. So the probability at most, small or equal to, so it is smaller or equal to 2, so it's 0.2 plus 0.2 plus 0.5, which is 0.1. So those 3 added is 0.5. The probability that at least, so if we go to at least 2 learners, okay, so that is probably going to be the wrong one. At least 2, so that plus that plus that plus that is actually 0.7. Okay, so that is the incorrect one. The probability that between 2 and 5 learners are absent on a given day. So now we assume that it is inclusive. So now we have that one. So it is basically interesting. So those two are asking the same thing, just in different question sets. So the probability that at least 2 and assume 2 and 4 inclusive, that is actually asking the same question. So both is 0.7. So this is great. I like this because this really would help in a lot of the questions that we deal with, because that, with my English not my first language, that is definitely things that you really struggle with when it's crunch time. Now, and it's still to figure out what at most and at least and those things mean. Great stuff. Okay, so basically I am going to stop there. We've got like 2 minutes, 3 minutes left. So then next week, yes, we're gonna, I think there's every week there's gonna be, let's just look at 1 or 2 things that I haven't added, and then we just continue. So next week we'll definitely complete binomial, we will complete Poisson, and we will start with the normal distribution as well. So next week we'll finish study unit 5, and we will definitely start with the normal distribution. Okay, so that is it for today. Next week, I know it's a public holiday with Friday, but I'm just continuing on the Saturday as normal, and I will record in any case. So, but I'll just continue on the Saturday as normal. I don't want us to lose some time, because we basically have, let me quickly check, 1, 2, 3, hopefully 4 Saturdays. If I'm right, you guys are writing the 18th still. That hasn't moved. So so we actually have, oh, it's good, it's on the 18th and not the 15th. So
sorry, Jean, are we writing
yes.
the 18th?
What did you guys have?
My exam says the 15th of October.
Oh, flip, is it the 15th? I was hoping it's the 18th. Okay, so the 15th, so we've got 1 Saturday left. 1 Saturday less, so we'll manage to make that. Sorry, I'll also just check on my timetable that I've received. So if it is the 15th, yeah, don't let me know. I always had the other date in mind, but shucks, okay. So we work towards the 15th, but that gives us still 3 Saturdays, so it should be enough. If it's not, we will then have some classes in that week of the 11th to the 14th in any case, just if anything is still needed to finish up. Okay, great guys, have a good weekend, and we will see next Saturday again. And please, again, post questions if you have questions around the next of the studies units for next week. So even on discrete, if you discrete, binomial, Poisson, and normal, and even if you pick up something on the previous chapters that you now suddenly see we haven't covered, please post it on the WhatsApp group, and I'll just add it. Okay, cool. Let's stop the recording. I will post it later today.